So you should be good.
Thank you all for coming, and thanks to Wildland for this beautiful facility, which we have returned to with their members after a 5-year hiatus, and we won't talk about why that was, because that's not good news. But thanks for coming. I'm Don Williams. I'm president of the Herring Ponds Watershed Association, and with my co-chair, Jack Gideon, I also am co-chair of the Water Quality Committee. So we're doing some good things, but tonight is David Gould. David is talking about restoring Plymouth one project at a time. It's actually good news about things that Plymouth's doing for the environment, and David is the main reason for that. We met David in the Herring Ponds Watershed Association when he and Herring Ponds Watershed Association formed an amazing partnership. David is an excellent partner. He has loaned us instruments, bought us instruments. He has helped us defray the cost of the water testing that we've done. He's gotten grants for runoff remediation, both the design and the construction portions of that, 3 of them on Great Herring Pond alone. He has helped me learn water chemistry, which I was in dire need of. No, I have a degree in chemistry, but all chemistries are different. But the scientific approach is what's important. Gathering data, analyzing data, and doing something about it. That's the part that usually doesn't go very far. And speaking of grants, David has brought in 16 million. That's with an M-I-L-L-I-O-N and 6 zeros after it, of grants in the last 10 years. I think that's amazing. And most importantly, and most recently, David has been instrumental in helping Herring Ponds Watershed Association develop and start to implement at least, our water quality plan. We have had 2 out of the last 4 years, we had cyanobacteria blooms, and we're escaping last year. We escaped last year. Jury's still out on this year, but I'm optimistic. But still, we haven't done anything, really. It's just the luck of the draw, the weather, the temperature, and all of that kind of thing. David is the real deal. I have not met anybody in town government ever before who cares this much about the environment, who cares this much about the trees that can't move by themselves, they can't run away, the fish that have no choice but to be in the water. And David is their hero. David has given lots of lectures that I've listened to, both here and at the Arts Center, where he talks about his work in herring and water quality and public health. I mean, he's interested in public health because of the cyanobacteria, which he gets involved in. And the results that he's had, if you've ever heard his talk on herring, it's really cool because they actually caught herring, tagged them, followed them up the stream the first year without doing anything to the dam, okay? Tracked the ones that came back and how long it took them to get up, how many of them it took got up. Wow. I mean, it was really scientific, and I should give Abigail Archer some credit for that, but the science was part of both of them. and the concern for the environment was part of both of them. And tonight, without further ado, David Gould.
Well, that's an introduction.
You earned it.
Thank you. So thank you all for coming out tonight. As Dawn mentioned, this is going to be a presentation on river restoration. So I've been with the town for about 22 years this Thanksgiving. And so we'll talk about a lot of the work we've done within that time frame, but we're going to talk specifically about the restoration projects amongst all the other work we've done. We won't talk about a lot of the stormwater improvement projects. Dawn mentioned some. We've done a lot in these other watersheds, but we're just going to focus on restoration for the project tonight. I'd like to think that anybody who works in the environmental field loves nature in general, but there's always one thing. For me, I'm very paradoxical. I love fish and I'm a river nerd. I love rivers. I love everything about them. I love the people that like rivers. Some of my best friends are just people like myself. We talk about the nerdiest things, right? Like pit tag and fish. And then if you notice, I went to graduate school actually in Arizona. So, right, couldn't be more different. I used to have a professor who said, if you want to learn about water and you want to study about water, you go to the desert. Makes sense, right? So I have all these rivers that I love in my life. Town Brook is one I played in as a little kid. But I think of rivers like the Merced, you know, in California, or the Salt River in Phoenix, or there's crazy little river called the Santa Cruz in southern Arizona, actually flows into Mexico and comes back into the United States. All these great rivers. So anytime I can talk or work on a river, that's what truly makes me happy. Rivers are to me what, you know, shorebirds are to Brian. So think of it that way. So I'm going to walk around a lot because that's what I do. I'm going to ask you all questions, so don't think you're just going to sit there. You all brought your calculators, right? Because we're going to do a little H&H analysis and calculations, right? No? We'll talk a little bit about that, but we'll just make Dawn do the calculations. The rest of you can sit back. So we're going to start with really important things. If we can make it work. Let's see. Or maybe not. Did it pause?
Come on, okay.
I can do it the old fashioned way.
I'm okay.
There we go.
There it goes. I don't know what I did.
So important things.
Thanks, Jeff.
So who's going to be brave to tell me what they would be? Not you.
Yeah.
Yeah, why? Why would you be a cat?
Kind of a chill, like, relax.
You're brave. I'm going to give you a commentary. Anybody else?
Oxford,
Why?
because they're incredibly cool, they make beautiful nests, even on high tension wires.
Okay,
I love to look at them.
okay, I like it. So that's what I would be. We're not gonna go over the obvious physical similarities. We're gonna talk about what they do. So beavers are amazing, and they have this outsized influence on their environment, and they create lots of habitat for other animals, right? A lot of things depend upon beavers and the work they do. So that's why I would be a beaver. So just real quickly about marine environmental affairs. We do three main things that we really try to focus on: acquire and permanently protect open space, manage that open space, and then restore habitat. So those are our core functions. And we'll talk mostly tonight about the restoring the habitat component. So I could give the whole presentation on restoration, but we're not going to do that. So we'll just go through some slides, but I want you to at least have some background. So some people, one of the terms you might hear now a lot more over the last few years is that term rewilding. we used to refer to restoration. I still use that phrase, but probably more interchangeably than in the past. But some thoughts and concepts. There's all kinds of thoughts about restoration. And the reason I mentioned specific points in time, what are you actually trying to restore it to? Are you trying to restore it to its original origin, 12,000 years ago, last ice age, or before European contact? And you got to think about those things. And we do, we think about those things. We never try to do a single species restoration project. So if you're focused on just restoring one particular species, that's a really short-sighted approach, and we never try to do that. So if you hear someone talking about, like, we're going to do this restoration project for this one reason, that's probably not the best approach, and probably need to be a little bit broader in your design. One of the interesting things, obviously, climate change. I remember years ago, there was always this discussion when you do a restoration project and you do your planting plan, make sure that you focus on nothing but native plants. Here we are 22 years later, and I think I'm not even sure what a native plant is anymore, because in 50 years, maybe the plants in mid-Atlantic are going to be native here as the climate changes. Should we be at least thinking that maybe now what we need to do is start putting mid-Atlantic plants up here, because those are the plants that are going to be here? Those are things we think about. You can go down some rabbit holes, but it's important to think about those things. And then restoration in an urban setting is very different than doing one in a natural setting. And a real quick example, if I'm out in a very natural, open, lots of open space, and I want to do a river, I can let that river meander through the valley and move all over the place. But if I'm doing an urban restoration, it might have to be a little bit more heavy-handed, because I need, ultimately at the end, I need that river to go back under that bridge properly, right? And not wash it out. So I have to be a little bit different in my approach. And we'll talk a little bit about that. And the last one is process-based, very much about process-based restoration, which is trying to do a restoration in which once you're done, that's just the beginning, if that makes sense. That stream or wetland is going to evolve over time. It's going to change in the processes that make that wetland or that stream channel. You want those processes to happen now, right? So you're sort of jump starting a process. But once you're done, that's just the beginning of allowing that system to function going forward. There's some folks out that we work with out in Utah State University. They call that, they have a great term, they call it PBR, not Pabst Blue Ribbon, but process-based restoration. And they have a whole program just about that. And they also have what's called a low-tech process-based restoration. We do a lot of work with actually beavers and beaver dam analogs and post-assisted log jams, so they're not using heavy equipment. So they're calling it a low-tech approach. So there's lots of places you can go with process-based restoration. Our approach is always watershed-based, so we're going to look at dams, we're going to look at culverts, we're going to look at stormwater, and we're going to look at land use. So if we can work in a watershed and we can do all of those things, we have a much better chance of making sure that that stream system, that wetland, or that habitat is going to function properly for the long term. Again, process-based. Don mentioned in his introduction, actually, partnerships. I can't even really remember all the different partners we've had on all these projects on state, federal, nonprofits. It's amazing the people I've been able to work with and meet. Last week, we were working on our bypass project. Does anybody know Alex Harrow from USGS? He worked at a place called the Conte Lab out in Western Mass. And he's probably one of the top 3 fishway designers, the hydroelectric dams in the world. And I met him years ago, incredibly brilliant man, very nice. And I asked him if he would just sit on some Zoom meetings when we're doing our bypass design. And he just shows up and helps us out and then goes back. And so we've met some amazing people, but partnerships are critically important. Technical advice, of course, at the end of the day, you need the money too, right? So that's important there. Building trust and confidence. I talk to a lot of different groups about dam removal projects and trying to help them have guidance. And it always amazes me how many watershed groups will ask for advice. And I'll say, well, have you done anything in the watershed other than so far, like a small stormwater project or a small land acquisition? And they're like, no, we just want to do this dam removal. I'm like, how many dams in your watershed? And they say 3. And I say, which one are you working on? They're like, oh, the biggest one. I'm like, so you want to start with the most complicated, most difficult project? And so I always try to guide them and give them a little advice. Sometimes before you tackle those enormous ones, build a little trust and confidence. And we tackled small projects early on, which I think were critically important. All right, so again, you're all participating in this process, so I want you all to close your eyes. And I mean it, so I'm gonna walk down and check. You better close those eyes. I want you to think about, in your mind's eye, what's your most idyllic stream look like? What's that perfect image of a stream in your head and what that would look like? Try to envision that. Everybody have a vision image in their head? All right, so open your eyes. Raise your hand if it looked anything like that. Yeah. Beautiful azure blue, green landscape. Nice flow to the stream. Anybody? Yeah. What about this one? No? We usually get some people love that. You know what they typically like? There's no understory. Nice. Yeah, people like that.
That's why I don't like.
Anybody stream look like that?
Yes.
Really? All right, Plymouth, I love it. That's awesome.
Yeah.
Yeah, so what do you like about that? Because most people don't, most people cringe. Oh my God, it's such a mess. Yeah.
It's
So
crystal.
I guess what some people call a mess, we call complexity.
Yes.
It's its own mess by its own making.
That's right, there's lots of habitat, right? A lot of complexity. Gravel bar, riffles, probably a pool hidden in here. We used to call that large woody debris, now call it large woody habitat. Sounds better. Lots of overhang, cover, and shade.
Yeah.
Got a nice riffle with some dissolved oxygen building up there, so yeah, a lot of complexity there.
Yeah, definitely.
Anybody know where that stream is? Ooh, good guess, close. Ooh,
All right.
you cheated because you live near there, but you guessed. Well, so you can't answer any more of those questions. So Wellesley Brook is on Sandwich Street, right near Brookside Ave and Nook Road. And that's where my dad and my grandmother lived. And that probably would be my natal stream, if you will. I played in that stream a lot as a kid. We'll go over some slides later and show you what we did there. Pretty interesting little stream. So real quickly, restoration 101. We talked about complexity. So habitat complexity equals habitat diversity. The more diversity you have, the more plants you have, the more insects you have, the more creatures you have, the more fish you have, right? So it all starts at the bottom and comes up. So without that complexity of monoculture, we'll talk about that when we get into bogs a little bit. That's the thing about cranberry bogs. One plant, that's not diversity. So talk about that a little more. Messy is good. All kinds of funny anecdotes about working with contractors for the first time, trying to get them to understand, like, no, I really don't want it super straight or super 90 degrees. Like, I want it messy, and yeah, you can do things. And they're sort of looking at you like, you don't do messy, you know, and trying to get them to understand, like, this is an interesting one I always talk to my staff about. Inefficient rivers are good. So it's not about trying to convey water from point A to point B. I want that water to go from point A to point B and hit everything possible in the way. A fallen tree, a bank, a rock, a gravel bar, a riffle. So inefficiency when it comes to rivers are really good. Riparian upland plants are vitally important. Try to focus on that too and talk a little about that. And again, what we're really trying to do is restore the processes, and we'll go over that a little bit more closely. Lots of homework. That is my cat. That is my little buddy Gibbs. He likes to help me when I'm over. I work on my laptop. So homework, we do a lot of work when we do one of these projects. So we look at topo and groundwater. Obviously, we have to delineate wetlands. We look at all the different flow regimes, seasonal, flood, bankful. We look at putting in piezometers, so we know the fluctuations in groundwater, so we know what the base flow is. We do HEC-RAS model, which is a model of streaming. We do H&H, hydraulic and hydrologic analysis. We do soil analysis. And then we have a whole myriad, especially in Massachusetts. Probably, other than California, Massachusetts is probably the most difficult place to permit a project. So a whole myriad of permitting that we need to go through. So when we do one of these projects, there's a ton of time and energy and detail into these projects. And then we build a stream that everyone thinks we just went out there and dug it, which is always kind of funny because there's so much work that goes into it.
Yeah.
So real quickly, does anybody know a fluvial geomorphologist?
No.
All right, but you can go home and use that term now, right?
Yeah.
That's a good one. Yeah. Yeah, so fluvial geomorphology is really, it's a study of how water shapes the landscape when you think of it. So you've heard of geomorphology probably, but it's just basically studies how water shapes the landform. So we're always, that's something you would study when you're really a river nerd and really want to know how that works. Just real quickly, basic stream morphology. You've got a straight channel here, pool and riffle. This is when I refer to sinuous, and we'll refer to that in some of the other slides you'll see. This is a sinuous channel. We'll have riffles, which are those really shallow kind of areas that you see that act as grade control, where water sort of runs over the gravel and you see it sort of getting oxygenated, which is really what's happening. And then we have what's called a fallway, which is a great German line. Fallway is essentially where the main flow is going, and that can vary depending upon the river. In this one, you see it going to the outer banks. Any good paddlers here? Anybody love to kayak? So you ever paddle and you think of like, you probably don't even know you're doing it. You're looking for that fallway, especially if you're going upstream, right? Because you're like, where's my least path of resistance, right? When I'm paddling upstream. So you try to find out where the fallway is and you're like, okay, I'm not going there. I'm gonna hug the bank. There's a little more friction over here, that kind of thing. That's what we're talking about. Real quickly with dams. So rivers, obviously everyone knows they move water. One of the important things they also do is they move sediment. So they move sediment downstream, they create lots of spawning habitat, not just for diadromous fish, which are the fish that go out to the ocean and come back, but for resident species too. Resident fish will also utilize different parts of the stream channel during different life cycles. And then with the dam, you put a structure here. Well, I guess it disappears there. You can see the dam structure capturing all that sediment. So now sediment isn't going all the way through the stream channel. It's getting caught up behind the dam. It's creating that wedge that we talked about behind the dam. So anything downstream of the dam is now what we call sediment stock, because it would normally have sediment building up shoals and banks and those kind of things. Now it doesn't have that. So you're starving that. You're starving it of wood and other vegetation. The other thing that's really interesting, especially now with climate change, is you're creating a giant bathtub of water behind that dam, and it's sitting out there in the sun like this summer. So if I'm a cold water fish and I'm a trout and I'm this guy, and what would be 60-degree water is now 90 as it comes over the top, that's not so good for me. Does that stream have any chance of being a resilient stream going forward with climate change when it can't even have its basic temperature? So that's something that I always like people to think about too, is not only removing obstacles for fish passage, we're really trying to restore the thermal regime of these stream channels and make them resilient going forward. This is real quickly about culverts. Boy, there are culverts everywhere when you really stop and think about it. So culverts are just smaller bridges, if you want to think of it that way. But oftentimes they create very constricted flow, which can be what's called a velocity barrier. So certain fish, like rainbow smelt is a great example, very weak swimmer. If you put a culvert down at the head of tide and smelt's trying to get through that, they're not going to get through that. It's too strong for them. They won't be able to swim through that. The other thing that can happen is you get that perch flow, that sort of drop. And if the fish is coming up, they're not going to be able to get into that pipe. So culverts are another thing that we work on in terms of improvement of fish passage. And then it goes beyond fish too, because we can enlarge those in such a way that they become significant improvements for terrestrial passage as well, for lots of terrestrial critters that use rivers as spoilers. All right, so we're going to talk about some of the restoration sites. And if someone has any questions or anything, feel free to stop me and ask. It's nothing formal about this presentation. We're just having fun. So feel free to raise your hand if you have a question. We'll go through these sites and talk about some of them, and I'll try to point out some of the highlights. We'll start with cranberry bog restoration real quick. So most original bogs were carved from wetlands, from natural wetlands. That's why when you look from an aerial perspective, most of the old wetlands have these really sort of cool organic shapes to them because they took the shape of the natural wetland. The ones that are really rectilinear and perfectly squared off are usually later. And then there's what's called isolated ones, and then there's the run of the river, like Eel River. So they actually built these bogs on either side of the river, straighten the river and use that for water. Those are really impactful to streams. What's interesting is sort of this history of cranberry bogs in southeastern Mass, where the wood was harvested because oftentimes they were Atlantic white cedar or great wood that wouldn't rot. So they used them for shingles and fence and other products. Then they went in and they would harvest out the peat in the iron ore, especially around here, right? Federal Furnace. There's a great book called Cranberries and Cannonballs, speaks to that kind of thing. Anchors, tack, forge, all that from the iron ore that was available here. So you cut down the forest, you've dug out the wetland. Now what do you do with it? Well, throw some cranberries in there, right? And then we have cranberry bogs. So that's oftentimes how a lot of our bogs come about. Massachusetts is a lot of increased competition, especially with Wisconsin. Those newer bogs that they created out in the Midwest, rectilinear, use very little water, hybrid vines, produce more barrels per acre, and really started out competing Massachusetts. So you see a lot of bogs, especially in this area, Plymouth and Carver, actually getting out of farming, and that provides an opportunity to do a lot of restoration work. Again, cranberry bogs, monoculture, right? So that one plant, that lack of plant diversity, not there aren't some other plants in the ditches and that kind of thing, but pretty much limited to a monoculture. Negative impacts to wetlands, sand deposition. So those of you who ever, you know, like I always thought every cranberry bog owner in the world was against me because I wanted to play hockey in the winter, and then they put sand on the ice. Why you always do that? It always makes my friends mad, right? But what they were doing was trying to drop sand in the ice, so when it melted, it would help the vines rejuvenate and grow. But if you do that over 100 years, all of a sudden you've got, you know, anywhere from 6 to 18 inches of sand over that peat layer, which is the wetland that you're really trying to restore to. So it's an inherent challenge. If I want to have a wetland back in this cranberry bog and I've got 18 inches of sand over that peat, how do I do that? So that's one of the challenges when we do these, is to restore that wetland hydrology. And there's several different ways to do that. The other neat thing about these sites is that native seed bank. When you can turn up that sand and get that peat layer exposed, it's amazing how quickly that native seed bank that's been buried for decades comes back to life so quickly. And what that allows you to do is obviously have a whole new diversity and complexity of plant species to start growing pretty quickly. Talking about Eel River here. So Eel River, I have a good friend of mine, Brian Graber, who grew up in Stoughton, but worked for the state for a bit and is now the director of restoration for an organization called American Rivers. And he's a great friend, but he's also one of those friends that you can go to when you have a crazy idea and he's going to tell you you're crazy. So when we were dreaming up Eel River, I said, I know who I need to talk to. I need to talk to Brian because he won't tell me I'm nuts. And so Brian and I went out there, and one day we walked the Eel River, and to say it was raining sideways is an understatement. We went back to Watershed Cafe when we were done and had the best hot cocoa you've ever had. And literally like your undershirt was wet. That's how wet it was. But he told me I wasn't crazy, which was what I needed to hear. Because I said to him, I want to do a project where we do one dam removal, replace 2 culverts, restore 40 acres of cranberry bogs, do 6,000 linear feet of stream channels, install over 1,000 pieces of wood. So usually that's 4 different projects in and of itself. But I said to Brian, I'd like to do that as one project, super holistic project, to see what happens. When we talk to some folks, they would tell us, break it up. It's not gonna go well. You're not gonna find money. We stuck to this approach, and I will say it was the easiest project we ever worked on in terms of getting funding. People saw the big picture. Fish and Wildlife Service was like, yes, we're on board with that approach. Let's do that. So sometimes it's good to have people like tell you, like, yeah, you're going down the right path.
Great.
And again, bridal shiner, brook trout, and box turtle. It was interesting, box turtle. The state told us there were box turtle out there in the surrounding woodlands. I was skeptical. We had a permit condition. We had to walk the bog roads before construction equipment started every day to make sure there was no box turtle, so equipment wouldn't run it over. It was literally the last month of a 9-month construction window. And there I am walking it again, looking in the morning like box turtle, no box turtle. I've done this walk every day for 8 months. There's no box turtle. Box turtle. So they were right. So so a lot of neat species out in Eel River. And I don't, most of you folks remember To the left is the old bog cells, and you can see some of the remnants of what was the natural stream channel. But you can also see all the linear ditches, perimeter ditches, and then all the berms separating all the different bog cells. This was the dam on the upstream side. Actually, aesthetically, one of the prettiest dams I've ever seen. Really pretty. Not that I felt bad about taking it out because I needed to, but aesthetically, it was a beautiful dam structure.
How old was that dam?
This was early 1800s. It was a stave mill, so they made wood barrels. Very pretty structure.
Yeah.
This, you can start to see some of the construction, and you start to see a more sinuous stream channel coming in, filling all those ditches, bringing up water. By filling in all the ditches, we get the water to come up a bit, and then we'll literally go in with a backhoe bucket of the excavator and turn that sand and peat layer over and churn it up and allow that cranberry mat, which is very tough and very dense. And by breaking it up, we mix the sand and the peat together, and we allow the groundwater to start coming up through that and activating that seabed. But if you think about 40 acres and having to dig 40 acres, it's a lot of work.
So, David, from the time of your first meeting with Brian and the rainy day till completion of this project on.
That's a great question. That's why I have short-term memory loss. Because I always say to people, if I remembered when I started a new project, how long the last one took, I wouldn't do the next one, right? But it's probably a good 5 years from the time of concept, but we've had others.
Is this still in the process of restoration or?
No, that's done. Yeah. I'll show you some pictures of it after. But I'll give you an example. The bypass project of working on Town Brook. I started dreaming about that probably 2004. Yeah, so you get these crazy ideas, right? Foothills Preserve. Most folks know that. More recent project, not far down the way on Beaver Dam Road. It's a really nice mosaic of stream. BVW is bordering vegetated wetland, open water, some really nice dabbling duck ponds in there that we worked with Ducks Unlimited as a project partner on, and some upland meadow that we're trying to restore for pollinator habitat, which is one of the newer components of these projects we've been working on. Water control structures were all removed. There were 2 remaining weirs as part of the Foothills project that were still on the Tidmarsh Sanctuary, and we removed them as part of this project. It was about $1.5 million project. What's nice about that is the town put $40,000 into that entire project, which was really kind of nice. And that was for the plants. So this is Foothills. You can see Beaver Dam Road there in yellow there. And this is let's go back there, see if I can give you a good reference point for those of you. This is that irrigation pond in the very back before the pine hills, the real pine hills, not the development, the actual pine hills, but this is that irrigation pond. That irrigation pond is back here, but you can see what was cranberry bog. You can see stream channel being restored here, a larger stream channel through here, dabbling duck habitat, and churning up of all that peat to allow groundwater to break up and come through the surface.
So physically, you don't remove all the sand.
See that pond?
Yeah.
This is a much bigger one. This is an area we flooded out, and this you can see doesn't look natural, and it's not this berm. We call that our Nazca line, like you can only see it when you're up high. So what that is that berm will grow over, eventually grow up in vegetation and trees, and you won't really notice it. When you walk up there, you don't really notice it. You can see it from the aerial. But really what it was to the start of the reason why we did that was to sort of keep this water, if it got really high, and not flood warm water into the stream until everything was growing. A little bit of adaptive management that we were working. You can see the stream channel, very sinuous, lots of wood placed in there. We'll go over wood placement in a little bit. We try to build streams in the dry or as dry as possible, so if we can move water one direction while we build channel, we always try to do that. You'll see a lot of wood on the outside bends. You'll see root wads, shade and cover. So fish love shade and cover. If you envision this cranberry bog in its natural state would have Atlantic white state forest, those trees would be 70 feet high, a big storm would come by, the tree would fall over during a storm, the root water would rip up the bank and you have all the shading covered. So we can either take wood and do this, or we can wait 70 years for all those things to happen, right? So again, process, we jumpstart that process. We'll do this, and we'll also plant trees in 70 years. So one of the great quotes that was asked of me when we did Eel River was when the project was going to be done, and I didn't mean it to be flip, but 75 years when the white cedar is forested to mature, right? So lots and lots of wood, snags and brush and debris. Again, this bog surface needs to be churned up. There's not any wood or brush or slash, so we import all of that. It takes a lot of time and effort to do that. When we do that, we also get lots of holes running around because we're breaking up that surface. So we can put things like this in. These are raptor perches. So that when we do this process, hawks love to sit there and pick out all the holes. Again, lots and lots of wood. So
Where do you get all that wood?
yeah, so we'll buy it. Sometimes we have had projects where we have able to work with a developer who's doing a particular project. The challenge is we love the root wad. So what we do is ask them to cut it like 15 feet high and rip it out. We call that a statue with the root wad attached. And a lot of times people are like, I'm not doing that because it's a pain to do that. It's a pain to truck, but we really want the root wad attached. So in Eel River, we did over 1,100 pieces of wood, which is really what trout love, right? So we import a lot of wood because otherwise the forest has been eliminated and we need to start that process. We're going to talk a bit about Wetland Brook. Actually, before that, I'll talk to you real quickly about, see if I can go back and, on this slide, with all this wood, and I was mentioning the bowls. Who remembers on the Eel River when we had that giant fence? Does anybody remember that? The back bogs had that giant fence around it. So the back bogs were called 6 and 7. And that's where the Atlantic white cedars went. And we planted the Atlantic white cedars way in the back because they compete with red maple. So we wanted them upstream of the red maples where the wind streams form. Does that make sense? To give them a head start. And so one day I was out in that area. If you remember, it was this giant fence. And even had a deer wire at the top. It was probably about 40 acres that was completely surrounded by this deer fence. And the plan was to keep it up 3 to 5 years to allow those Atlantic white cedars to grow so the deer wouldn't browse down. So to give them a head start. So one day I was out there and it was the first year I was noticing that the very bottom of those Atlantic white cedars, which is a whole nother fascinating sort of fabric off those trees, the bottoms were being girdled by holes that were getting eaten. And I was really worried about that.
Yeah.
So started walking the perimeter and I see like little holes under it. And I'm thinking, okay, so we've got some predators that are coming in here. What should I do? And so we started filling those in because nothing can get in this fence. I'm not really thinking holistically about the site. We're just like, I can't have anything in the fence. I built a fence, don't come in here. And then about a month later, I was walking through the site again. And I was walking across to some trees that I wanted to check on. And I was in this little, right where the stream was, and I looked, and there was a coyote looking at me. And he had a bowl hanging out of his mouth. And I went, what is he doing in here? And then he ran. And then I walked about 10 feet and I went, oh my God, that's my solution. And so I told my guy, stop walking, like the deer aren't gonna crawl under the fence, right? But let the coyotes do it. I was like, and we never had bull again. But because I was keeping the coyotes out and the foxes out, the population of wolves and mice and everything in there was exploding. And then so even someone like myself was trained to think like about connections, literally totally oblivious to that. And when I saw the coyote that day with the bull hanging, I thought don't block that. Let them get under the fence. The deer aren't going to crawl under the fence. So, but it's interesting. You're always learning, right? So Wetland Brook is that stream over on Sandwich. What's really neat about it is we used to have trout pools out behind it. And so it has a small population of salted brook trout. So salted brook trout are brook trout that take on an anadromous ability that can actually go out into the bay and feed in saltwater in the marine environment, which is really neat. It had 3 weirs. It had exotic duck ponds in it. Very strange, but true. It had previous degradation on the downstream, one of the downstream channels had actually been dug out by mosquito control. And they never stabilized it. And it's one of the few streams we have in Plymouth that's flashy. And what I mean by that is there's lots of stormwater runoff. So the runoff goes into the stream during an event and comes up really quick. Most of our storms don't do that because we get a lot of good infiltration. This one does because it's very urbanized. And so you get this really big storm flow event in a stream that's already been destabilized by mosquito control and just kept eroding away. And so we had a lot of folks in this neighborhood who were really concerned about it, and actually helped us gain some support. So the owner gave us a permanent easement over it, and we got some grant money to do the restoration work. So what that looked like, these were the weirs. They had exotic ducks in here, which I thought were neat when I was a little kid. But what was neat was out back in my grandma's house with a trout pool, so you could see trout, and knowing that trout should be down here, right? This is another one of those. So what's interesting, depending upon the fish species, that might as well be a 50-foot tall dam, right? If you're a small, fingerling trout, you're not going to get through that. So some of these even smaller structures can be really big impediments to fish passage. And so this is during restoration. You can see a lot of the wood on the side. You can see we're using geotextile fabric on the sides. We plant right through that, and lots of wood. This one we use is more of a it's a steeper channel, so it's more of a what we call a step pool than a pool and ripple complex. So it's a little bit steeper. And this is what it looks like right after restoration. Neat thing about this project was myself, the engineer, and one machine equipment operated this project in 2 weeks. It was super fun. This is the overflow channel that I'm talking about. So we kept the flow going down the main stem. And by having most of the flow go down the main stem, this would allow this channel to revegetate. And you can see there's a log here. It's actually paired. There are 2 logs underneath and one on top. And what that allowed us to do is if we ever wanted to have more water go through there based on the design and what we were seeing happen, we could literally get in with a chainsaw and cut that tree down, and change the elevation without having to get equipment back in. So that's why we did it.
Why did you choose to break off that other stream that went over to the Boyer property?
Because
Why did you choose that one versus the one on this side?
it's a great question. So the reason we did that was that had more base flow in it, this one that we used. And with the street there, not anymore.
Well, it isn't anymore, but that's where the ducks were.
Correct, and that's what we got rid of. Yep,
You got rid of the pond.
that's right, absolutely. So this stream channel had all the flow divided among 2 channels. There wasn't enough flow for 2 channels. The one on going to the right was not the natural channel, so we wanted to have all that flow back in one channel, so we increased the depth and velocity of that stream. So that's why we did that. This allowed us, this tree allowed us to do any sort of future adaptive management if we needed to change those elevations by just going in with one guy and a chainsaw and being able to change that elevation. You can see some logs going across holding the grade control there. And that's a photo from a few years afterward, looking pretty much filled in, lots of vegetation. These sites react remarkably quick. And again, that's a salt brook trout. So brook trout they're like pieces of art, right? They're beautiful. So to find those in pretty much the urban environment in downtown Plymouth is pretty amazing. So I think everyone knows I have a particular affinity for Town Brook. So we'll talk about that a little bit. Just real quick, 1.7 miles from Billings to Sea to Plymouth Harbor, drops about 90 feet in a mile and a half. It's pretty steep. It's that stream that we all learned about in history class when we were little kids. What's amazing to me about this is 7 dams in 1.7 miles. Talking about maximizing the water, right? Like, holy smokes, could you get anything else on there? And the town acquired a lot of the parkland and inherited a lot of these dams and fish ladders over the years through tax title and the mills sort of being abandoned. So this is a photo by our good friend Keith Logan. It's actually Town Brook. Those are the alewife. So river herring, there's 2 species of river herring, alewife and blueback. Town Brook's probably about 95% alewife and about 5% blueback. Main difference being alewife like to spawn in a pond, whereas blueback will spawn actually in the stream channel. They kind of come up a little bit later. I know I have lots of friends who tell me, oh, I can look and tell you that's a blueback and that's an alewife. I still can't tell, so I don't know how they can, but they really have to cut them open to know that, but anyway. So everyone knows this bridge, right? This beautiful little scene. So when we started working on Town Brook for every one of these scenes, we had one of those. So this was our first project. This was Billington Street. Does anybody remember this site? Yeah. Ginny remembers it. So there used to be a mill there. And what happened was the mill burned down. They never properly cleaned it. So it had old asbestos shingles. And then the top 2 feet of the soil became asbestos contaminated. So we had to clean that, send it to Ohio. And then this was the old fish ladder. And we talked to Noah about doing a fish ladder. And then Eric Hutchins, who's someone I worked with for over 20 years now, said, why don't you just get rid of the structure? And I said, you would help us do that. We'll gladly take out the dam. But most of the time, everyone up until this point in time was like fixing fish ladders. And I said, I'll do it, but I need some backup here. I need someone who's gonna help me and work with me on that. So that's what we did. So this was the first proactive dam we did in Massachusetts. What was interesting, the first year I was here, and you see that gap where the water comes out of that culvert. It doesn't quite get to the fish ladder. I'm a pretty good carpenter, but you should have seen me trying to fix that with plywood and keep the water in that fish ladder. What a nightmare. So this is a horrible structure for fish to try and get through. Challenges, industrial era, so lots of contamination at these sites. Fish passage very poor, water quality very poor. Public safety concerns, each one of these dams, when it hasn't been maintained in quite some time, is a public safety concern. And then, of course, we're in a very old area. We're in a National Historic Register district. We're in an area where some of the first mills, so we have this whole process called the Section 106 historic process. So lots of historic and archaeological permitting we need to go through to even remove some of these dams. 2002, this was the Billington Street dam removal, the first one we did. It was really the foundation of our program. It was one of the relatively smaller dams on Town Brook, but I think that was important again. It allowed us to do a dam removal, figure out what we were doing. It was the first one in the Commonwealth, right? So we were figuring out what we were doing. We were literally asking permitting folks, do we need this permit? And they would say, I don't know. And like, well, do we or don't we? Like, so no one really knew how to do this stuff. And so we were figuring out, and I'm glad we did this one rather than Holmes, which is a skateboard park. Imagine if we started with the biggest one. So it was kind of good that we started with a smaller one. It was a breakthrough for us and really helped build a lot of momentum. This is during the construction. If you folks remember, this was about a 2-week project again. We did it with an Army Reserve battalion, an engineering battalion that did it as a training exercise. So we were obligated as the town to provide them with 3 things: food, fuel, and lodging. So we worked with DCR. They gave them a cul-de-sac and Miles Standish to tent in. Every day we brought the town DPW fuel truck there to fuel all their equipment. And then we catered their breakfast, lunch, and dinner on site. That's what we had to do.
And they did it for free.
They did.
Wow.
Funny story about this though, again, complexity. I remember working a lot with the lieutenant on the time, and he would run a lot of the equipment and we would be placing stone. And he would say to me, David, what stone, how do you want the stone facing? I'm like, just throw it in the river. And he's like, well, we don't do that. Like, you know, how do you want this done? And so they graded this bank like perfectly, like MassDOT spec, 45-degree slope, completely unnatural. So they finished on a Friday, and on a Saturday, I had a couple of guys from the highway department in overtime come out and they messed that all up for me. But I had to do it after they left because it would have been fall. Yeah, the Army doesn't do messing. So that was fun. So this is a speed channel. It's relatively steep grade, so you'll see a lot of larger material in there. So we worked with Abby on a project when she was in graduate school, Abby Archer, who was a student. So we did this project. I would watch it every year. I would know that fish would get up from the lower part through the top. But I always thought to myself, how do we quantify that? Like, how do we prove that it really was successful? So Abby Archer, who was a graduate student at UMass Amherst, was working on her graduate thesis. She said, I'm interested in that too. And then we worked with Alex Harrow, who's the gentleman I mentioned earlier at the Conte Lab, and they actually built a model. I don't know if anyone been to the Conte Lab. It's off the canal on the Connecticut River. It's this giant building. They take water from the Connecticut River and run it through the building. They made a mock-up of Town Brook real river herring that they put in, and they can run that model. It's an amazing site. And so we did that project and it proved that about 94 to 96% of fish that enter that restored section of stream get through it. So we had proof that that stream was effective and fish could get through that.
Yeah.
Yeah.
Question, fish ladders,
Yeah,
did they work well when they were first built, or were they just a bad design from the beginning?
yeah, so fish ladders are fascinating. So fish ladders, there's all kinds of different types of fish ladders. Pool and weir, Danil, Alaskan steep pass, all these different types, and they all function differently. Fish ladders are usually designed for one particular fish species. They usually don't pass multiple. Some do, but not well. So a lot of the fish ladders that you saw in Town Brook were strictly for river herring. Some worked okay. I would never say any of them worked very efficiently. And by that, they were probably passing maybe 40 to 50% of the fish. I'll show you some pit tag data that showed like Holmes was even worse than that. So fish ladders are never really effective. And the other downside of that is, even though they may pass some fish, they do nothing for the water quality of the thermal regime or all those other issues that we're looking at with rivers, right? Challenges again, fish passage, off Billington. This was another project we did on Town Brook. Again, myriad of different project partners you can see real quickly. This was a dam, this is what we call a pool and weir fish ladder, so it had built-in concrete weirs in it. One of the more challenging ones, what we call a traction flow, which is the water that should be coming out of the fish ladder to attract fish up to it, is immediately adjacent to the spillway. So the fish got easily confused by that. And that's one of the challenges, is the traction flow when it comes to a good fish ladder. This is the removal of that. So if you envision beforehand, that entire area there would have been underwater, and that's restored stream channel. And that's how quickly they grow in, right? So that's a few years later. I want to talk real quickly about a bunch of different techniques we use on various projects. This is actually Brewster Gardens when we were restoring the stream channel. This is geotextile fabric. We actually call it an encapsulated soil lift, but if you ask people out there, we call them burritos. So basically what you do is you fill that, pull out that geotextile, fill it with soil, seed it, flip it back over and stake it in place. And what it allows the plants to do is to grow through that fabric. That fabric will eventually photo and biodegrade, but in the meantime, all the plants have grown up and all the roots hold your bank. So kind of a neat little system. This is what we call, again, trying to work in the dry, right? So we rerouted the river during construction to kind of build a stream channel and dry. That way we try to limit how much of a mess we make downstream. This is actually stake. You can see some very beginnings of willow cuttings in bundles. We call that a fascine. And you can see even more of that. So those are cuttings, but we usually plant them in the dormant season. But when the growing season comes, those willows start rooting everywhere and really hold the stream. This was the first dam project. You can see we've got some geotextile fabric on the side holding the slopes, but very quickly these areas seed and grow in. This is a kind of one of the historic and archaeological techniques we do. So oftentimes these old raceways that are some of the historic components of the project exist. And we try to blend the new walls in with the old. We don't try to always mimic it because we don't want to try and copy it because it always looks kind of fake and artificial, but we do try to tie it in together so that you have an aesthetic that looks nice overall. This is a wing wall. We do a lot of the bridges, precast concrete for structural integrity, but then we come in with the stone and we'll actually cover them to make them and make them look nice, but also meet some of the historic and archaeological permits that we have. So this is one of the bridges. This one's actually a Plinko. You can see the stream's all built up, it's dry. So one of the best days is when you're allowed to, you build your whole stream channel, however many linear feet, and then you get to let water go through it for the first time. That's always one of the best days. And then you can see the precast arch concrete. We found old photos of these bridges that were out there, and they actually had arches. So we replicated the arches, and then we just used the stone to improve the facade. Oftentimes, because of the fish are running in the springtime. Town of Plymouth, pretty busy place in the summer. So oftentimes with our time of year permits, we're doing all this work in the winter time. So snow on the ground, heaters and pumps, and doing a lot of difficult work in the winter time because that's the only time we have to work. So you often see construction for us in the winter. And snow. Yeah. And then there's that same bridge, but with all the snow on the side. Punka, which was upstream, this one's an interesting one because we must have a town meeting member too here, right? Yeah, so town meeting allowed us to buy this, so we said at the town meeting, we have a contaminated site with an old unsafe dam, could we buy it? And they allowed us to buy it. We then got over $500,000 to do the site cleanup because it's an old mill site, contaminated soil. We had to clean that before we could even do the restoration. Take down the buildings. You remember the two buildings over there, the Plymouth one was actually pretty massive. Got those buildings down and then did the restoration project. This was the dam, if you remember. There's only supposed to be one spillway, but you can see already breaking out to the right. So really old structure. If you go up to the site now, you walk this little path, that turbine ring right there is actually out. We stayed that and put it on the path if you ever want to go up there. Kind of neat, but that was the old building. They actually, part of the building covered the brook. The brook actually ran under it. It was so big. That was the back side. Yeah. Yeah, so that beautiful old mill owner's house behind it, and this was the structure that was there. So that's literally right after construction. And you see we place a lot of wood. Try to allow some places for small creatures to have before vegetation grows up. The snapping turtle, the day we put water in the stream, he started moving upstream, literally the day. So both fish, I've seen fish, eels, and the snapping turtle on various projects move up in the stream channel within hours of releasing water. It's always fascinating. This is that same stream channel, the former town, which was all underwater, starting to go back up and vegetate, and areas covered again, which is really nice to get that shade and cover back over the stream. And folks most know about homes, high hazard dam. So the only high hazard dam that the town owned, meaning if it failed, it was going to do some serious damage to life and property. We did a lot of work on that project, not just dam removal, stream work, bridge replacement, new utilities, and the new park. So that was during construction. What's interesting here again about storage and archaeological, you can see these four sort of tabs. Those were the giant ovens that they used when they would make the cut nails that were made at the back. We actually found those. The archaeologists suspected they were in that location, so we had to dig there first to see if they were, and sure enough, they were there. So that's all documented. But we find a lot of interesting history. You can see two iterations. This was the first fish ladder that was put in. That wasn't very effective. And then there was a second fish ladder in the 70s put in running this way. That wasn't very effective. We'll talk about that a little bit real quick. That again was the project site in the wintertime. Yeah, I can make a big mess. That was the site. I don't know if you, that's an aerial of the old park. You can see the skate park and the basketball court and the impound and the dam. And that's a similar image of it afterwards with the new park and the stream channel. Similar angle. And dam was right here, so all of this was underwater, so that's all your new stream channel. The stream in the previous park was actually buried underground, so we took that out. We call that daylighting, and we restored the stream back to daylight. So that was another component, and then also a whole new bridge, all the utilities, roadway, sidewalks. This was about a $7 million project. The town put $2.5 million in, and that was for the bridge and the utilities. Everything else was grant money. So to your question about the fish ladder, did it work? So we did some pit tag studies, both before and after on homes, again, to evaluate the success of that project. So pit tags are little transponders that we actually put inside the fish, and we set up a bunch of antennas, and when the fish swim through those antennas, it gives us data and we know where they are and how quickly they went through. So it's like when you go on the Mass Pike and we track you from one exit to another and know how quickly what exit you got off. It's the same idea, same technology. So we did tag some fish before the home stand project. And that fish ladder, which was interesting, usually don't try to mix fish ladder types that I was mentioning, like the nil and steep pass. Holmes Dam had both the nil and steep pass. And the reason you don't tend to mix those is one needs a lot of water and one doesn't. And so when you're sending water through these fish ladders and they both need different types of water, how do you run both of them optimally? Well, you kind of don't. So we were passing about 25% of the fish that got into that fish ladder at Holmes got through 24.9. When we were done with the project, we got about 92% passage through the restored stream channel. What I think is really interesting is this, which is these fish, if you can imagine, I'm a fish coming into Town Brook and I have to make it to Billington Sea. And at one point there's 6 dams on this. That's a lot of energy expenditure, right? So at Holmes, even the ones that got through, it took them about 4 hours to get through that project site, relatively small area. When we were done with it, we were getting 92% passage. We were measuring their passage in minutes. So saving lots and lots of energy to both get up to spawn, back out into the ocean, right? So that those fish can come back to spawn again. So really important in terms of saving them energy and time. So monitoring outreach, we do a lot. I'll go through this pretty quickly. Any herring counters here that we have? There we go. And we have, obviously you guys are a big part of our annual herring festival. And we have our underwater camera, which is fantastic. And we've done some art installations, probably trying to do outreach to get people to understand what it is we're doing and why we think it's important. This is our river herring and annual eel migration totals. This year, we don't have the official data. Last year, we were about 169. This year, we're going to be well over 200,000. It was a really good run this year. This is our camera box. So we have, as most of you know, this camera box live streams fish to the web, right? So it started at an inopportune time in 2020 when lots of people were looking for things to do. So we were live streaming to the web. I have some data, but I think it's already changed a little bit. So this is what you would see, fish going upstream through the camera box. We have videos that you can count. We actually use that data as part of our data population estimate every year. I think we're already, this year, I think we're up to 48 countries. So we have people from 48 countries around the world doing fish counts for us.
Our grandkids in Brooklyn do that.
Right, it's fascinating. The first day we ever did it was 2020. We got it live, but we hadn't even advertised it. We came in the next morning and we found that someone in Ireland had found it overnight and done a fish count for us. And we're like, how did that guy do that? How did he find that on the web? But it actually started doing counts before it even advertised. It's pretty neat. It's been one of our best outreach tools, for sure. We have some colleagues who work in England and some who work in the Netherlands, and they always compete every year against which country gets the most counts. So they always compete against each other. American eels is another species that we work on. As much as I love river herring, eels are absolutely fascinating. One of the coolest creatures you'll ever see, and the fact that they come right up through the center of town and are in all of our streams. Every single stream in Plymouth will have eels. It's absolutely fascinating. This is our eel trap, where the glass eels and the elvis will come up, and we'll trap them, give them a count, and then give them a quick walk over spring lane and put them in the jam so they can head upstream. This is one day. Those are all little glass eels. So there's about 2,500 glass eels that coming up in Town Brook on one day. Really cool. This is some of the artwork we've done. This is underneath Main Street Extension. Where projected images. That's actually all Town Brook fish. And when you walked under the bridge, you felt like you were immersed with the fish swimming around. Really kind of neat. So some of our accomplishments, obviously significant fish passage improvements, lots of water quality improvements. One thing to keep in mind is everything we do in Billington Sea or Town Brook also impacts the harbor and makes the water quality in the harbor much better. So getting a lot of benefits by working in one particular area. Contaminated sediment management, we've removed over 20,000 yards of contaminated sediment from all these impoundments on Town Brook alone. So that sediment that was trapped behind those dams that was contaminated from agriculture or from the old mill use, arsenic, lead. We've taken out 20,000 cubic yards of that and disposed of it. So if you're living, in front or backyard of Town Brook, you've had a significant ecological improvement just from sediment management. Of course, lots of new infrastructure for the town, utilities, bridges, removal of the unsafe dams. We've reduced lots and lots of costs for all that new infrastructure by doing it as part of a restoration project. And again, public space investments like homes and trails around these properties. And again, enhancing resiliency of these coastal streams to function going forward. So to date, I didn't mention, but in Massachusetts, a jurisdictional dam is any dam 5 feet or higher. If it's 5 feet or lower, they call it a weir, and it's not jurisdictional. If you're a fish, doesn't matter if it's 4 feet or 10 feet, you can't get over it, right? But for the Commonwealth, that's okay. So we have 6 jurisdictional dams that have been removed, 3 non-jurisdictional dams, 15 different parish within former cranberry bogs, and over 250 acres of restored wetland.
What's the meaning of jurisdictional in this context?
That means it's jurisdictional by the Office of Dam Safety, which means you have to have it inspected. The rate of inspection varies upon whether or not it's a low hazard, mid hazard, high hazard dam, and then how much maintenance you need to pour into that structure while you have it. So again, if you're going to have dams and they're going to have all these negative ecological benefits, you're also going to be spending a lot of money to continually inspect and maintain them.
So if it's non-jurisdictional, it's subject to no inspections.
Correct. As scary as that might be. Right. And there are also large non-jurisdictional dams typically associated with agriculture that can be in the excess of 5 feet, but because they're agriculture, they're exempt. Yeah. Yeah. Couple of interesting points. This was some guidance years ago from the Commonwealth. When they first came out with their dam removal guidance for municipalities, what was really interesting about it was this was the statewide policy, and all the photos were based on Plymouth projects, which was kind of.
David, I may have missed this, how many more dams do you target to restore here in the hall?
That's a great question. So there's only about, trying to think, there's 3 more dams that we're working on in Plymouth that we probably won't remove, that we're doing work on to maintain as structures, mostly out in North Plymouth because they provide some recreational benefit. And then most of the other ones after that are privately held. And we are currently to that point working with some private landowners to try to get them to remove some of these dam structures. Yeah.
How many total are there?
Including all the private ones as well, in excess of 50. Yeah, when I started, I think Plymouth owned 16 when I started. I think we have 5 left. Yeah.
How do you put the little device into the fish without killing them? Or do you kill some?
Nope.
No, but how do you manage to catch the fish and it's very small and the fish is big?
So it's literally about that big of a little tag. And we actually give it a small incision and stick the tag in, and it heals up.
Oh, so you catch the fish, put the thing in it.
Correct.
And let it go.
And release
Let
it.
it go.
Yep.
But it's a bigger fish, right? It's a big.
It's an adult.
herring. It's a herring.
It's an adult, not a juvenile.
It's an adult.
Right.
And then it stays in the fish.
No. Yeah, the tag, yes, the tag stays inside the fish. And we have had fish that we have tagged. Because we put those antennas up year after year. We have some fish that we've been able to document and come back 4 straight years in a row.
But they go up the stream and then they actually get back to the ocean.
Correct.
Okay, how do they go back?
They might
Same way.
Easier to do that.
Yeah. So one important note is that they're not, like, a lot of people think of river herring like Pacific salmon, which would spawn and die, but these adults can come back multiple times to spawn. They don't die. They can come back. Yeah. Again, another slide from a presentation that Commonwealth gave about their dam removal program that they were presenting nationally. And, for us, it was interesting that the leaders and advocates they put down for dam removal restoration projects in the Commonwealth, they listed the town first, which is always nice. Yeah. Some lessons learned, again, thinking watershed wide, building momentum and credibility, taking advantage of opportunities. We did a restoration at Brewster Gardens to lower the weir that was there. We actually cut off 1.5 feet. And then about 7 years later, when we replaced the bridge, we went back there and removed the entire weir. So we did what we could at that time, but we went back to do even more when we had the opportunity. So I always try to let people know, you can always go back and improve projects if you have that opportunity. What's important to some isn't important to others. I think this has been really important for things like town meeting. There's a lot of people who love fish in Plymouth and love nature. And I'll pick on FinCom members. Let's say FinCom members don't really care about fish or outdoors, but they care if they have to put $3 million for a new culvert. But if I can tell them it's going to cost them $1 million because we're going to get grant money for it, now that might be something they care about, right? So we need to sell it from many different angles and obviously keep making progress. There's some projects I talked about right here, actually. So we're working on a project right now with a landowner, the Capel Pinnacle Bog. Jeff Capel is a bog property surrounded by town-owned open space that we're working with him to restore. We actually just went through the MEPA process. Acquisition of this parcel will be coming to fall town meeting in October. So you hope we buy that as permanently protected open space. So that's another one you'll see. We're working with another bog owner, Chet Downingman, who owns the bogs out at the rear entrance of Morton Park, literally between Morton Park and Quality Preserve. So it'll be a great connection of open space. And then there's others to be determined. There's a group taking a vote today on a potential restoration project. I wish I could tell you, but I haven't got a text or an email yet. So hopefully tomorrow when we talk about some more projects. This is the Capel property. What's nice about this is the surrounding land is town open space, and it also falls within the zone 2 of the town's well open air growth. So it's a nice habitat, it's a nice restoration. These are the allium bogs that I mentioned. So this is Morton Park, this is Quality Preserve, and these bogs will be that physical connection. What's neat about it, it's one of only 2 tributaries to Town Brook. So we could actually restore one of those tributaries, which would be pretty neat. In conclusion, let's see if this will work.
A quick one. You work with other towns, like particularly Warren, to cross contaminate information about what you're doing, what they're doing.
Yeah, it's funny. I've had a couple of towns actually ask if I could come and help them on projects, and I have to tell them I'm not the state. I actually helped a couple of communities out in California last year, and I'm working with a group in the Ozarks, Northwest Arkansas, on some dam removal.
I mean, local ones like, Kingston, Bourne, Carver.
I work with farther communities more often than, yeah. I don't know, yeah. But other municipalities do reach out. We work a bit with Wareham and trying to help them on a couple of projects. And certainly always work with Pine Du Bois up in Kingston and Jones River as well. So, yeah. Let's see. If this actually, oh, it's playing here, but not for you guys. Oh, I'm sorry.
Brought back the
Hold on. Possibly, we're gonna exit the PowerPoint. And that'll solve all the problems, maybe.
It's just embedded in that last slide.
Hold on, I'm just gonna. And we're in. Oh, no, not in. I know. We're almost in. Okay.
There you go.
You started from.
So this is just a video, shows you some of the work in Town Brook. Is just a nice overview and a good way to close the presentation. You'll see all the projects sort of from an aerial perspective. So.
No lobster to help with fish.
What's that?
The rocks in the garden.
Yes. Yeah, especially at that site, they're actually placed very specifically to create chutes for fish passage. Yeah, it's very engineered. And this one working on the bypass project for that right now.
That were.
So that was a fish ladder that we upgraded in 2007. But we would like to revisit it and do a bypass around it. I promise that's the end. Mhm.
Is there how much of the brook from Billington to the harbor actually has the trail next to it? Only from the harbor up to the Chris Mill?
So it's basically from off Billington Street to Rooster Gardens, and then now, after last winter, you can go from off Billington Street along the sidewalk, the new sidewalk that was put in. There's a little footbridge at the upstream end of the former Plymouth impoundment, and sidewalk that gets you all the way into Morton Park now. So between a trail and a sidewalk, you can walk from Morton Park to Rooster or vice versa now for the first time.
Thank you.
Yeah.
That's great. Thank you so much.
Photography.
So that was drone footage.
Somebody had a card.
Yeah, that was a drone footage. Yeah,
Oh, so you send the drone out there to take pictures. from-
correct. We actually used a drone for the first time on homes to actually do the as-built survey of the impoundment. Because it's so wet afterwards, it's really hard to walk through. We actually used a drone for the first time to do the as-built survey, so that was a new one for us.
And you use that in getting the grants, right?
We use lots of technology, like the pit tag data. So we use that pit tag data to gain fish passage information, not only the dam removal project we did, but the 2 upstream fish ladders. And we use that data to get us grant funding to remove the next 2 dams. So when we do the data and the science, obviously it has value intrinsically, but it also has value in trying to secure money to do other work. Yeah.
Okay.
Jerry, would you stand up and take credit for getting David?
Thank you so much,
Yeah, very
David.
welcome.
We've been working together for a long time and really appreciate everything he did. We went on our garden club. You took us on a walk up that trail along
Yeah.
and I was so impressed with the restoration of Town Brook. So I wanted to share more of it with people.
Thank you.
And I hope you've all enjoyed it and come to more of our programs.
All of our board of directors raise their hands just so people can see how who's here. Great. Thank you for coming. Brian, did you have a question?
No.
Sure. Okay.
Thank you.
Well, thank you all for coming.
Thanks a lot.
They did it. Just wanted to tell you we've really been interested in the. Yeah, absolutely.
We do it. Feels fascinating because when I was a kid, like, oh, this is like that. What do you like to do? Used to have a tree out there. Where she would see like.
Yeah, that's what I'm doing.
Yeah, I did.
Don't worry.
So I remember.